Here we have AP calculus AB problem. Okay, let's go to the information. The values of functions f and g and their derivatives with respect to x are given in the table right over here. If k of x is the inverse of f of x, determine k prime of 1. So the question clearly says k of x is the inverse of the function f of x, and we have to find the derivative of k of x at x equals to 1. Okay, so since we need the derivative of the inverse of f of x, first let me write the inverse of the given function, that is f inverse of x. So I need derivative of the inverse of the given function, that is f inverse of x. So to get derivative, I have to take a prime for this one, that is f inverse of x prime. So there is a formula to get derivative of an inverse function. So that is 1 over f prime of f inverse of x. Let me write the stuff over here. So since the question says k of x is the inverse of f of x, then the derivative of inverse of f of x can be written as k prime of x equals to 1 over f prime of f inverse of x over here. Okay, our aim is to find the value of k prime of x, k prime at x equals to 1. So we have to plug in x equals to 1 over here. Then I'm getting k prime of 1 equals to, so on the right side also I have to plug in x equals to 1. Then I'm getting f prime of f inverse of, for this x I have to plug in on 1 over here. Okay, let me write 1. Okay, now I need the value of f inverse of 1. So for that, I'm going to consider two sets. Let me consider the set A, and also let me consider another set B. Okay, in set A, I'm going to take the values of x in the table we have over here, that is 3 and 4. In table B, I consider the values of f of x in the table, that is 1 and negative 3. So in table A, we have x. In table B, we have f of x. And f of x maps the elements from the set A to B. So that is when we take x equals to 3, what is the value of f of x? It's just 1. So 3 can be mapped to 1. So when x equals to 4, what is the value of f of x? It's negative 3. So we can map the element 4 to negative 3. Okay, when f of x maps the elements from A to B, then in its inverse, it is f inverse of x will always map the element from B to A. So that's a reverse order of this mapping. Okay, so here I said A contains the elements of x and B contains the elements of f of x. So if I consider f inverse of x, that is B to A mapping, so B will contain the elements, the values of x, and A will contain the values of f inverse of x. Here we need the value of f inverse of 1. So let's plug in 1 over here. So if I've taken 1 as a value for x, as I said already, so B in f inverse of x, B will contain the values of x and A will contain the values of f inverse of x. Since I have taken the value 1 for x over here, let's consider the value 1 in the set B. So when I consider the value 1 for x, then what is the image of this one in set A? That is 3. So this is the value of f inverse of 1. So f inverse of 1 is equal to 3. Okay, now what we can do is we can plug in this value 3 for f inverse of 1 over here. Let me continue the stuff over here. So k prime of 1 equals to 1 over f prime of, so for this f inverse of 1, we can plug in 3. Let me write it. So k prime of 1 equals to 1 over, so f prime of 3 is nothing but the value of f prime of x when x equals to 3. Now let's go to the table and get the value of f prime of x when x equals to 3. When x equals to 3, the value of f prime of x is 6. So that's the value of f prime of 3. So the value of f prime of 3 is 6. Now I got the value of k prime of 1, that is 1 over 6.